perform an activity to show that in series combination of resistors, so we're looking at series, same current flows through each resistor. So before we answer, let's understand what they are trying to ask. So do you guys recall this? I have two resistors connected in series. From this is the first and this is the second resistive length. So if I leave a ball bearing over here, what happens? Same current will pass through both, is it not? It will roll on both of the resistors, resistive lengths. So that's what they're asking. So in an electronic scenario, right, this is the gravitational scenario. So in electrical scenario, does the same thing happen? To check that, we are going to have a look at an experiment wherein I have two resistors, right? And connected in series with both is two ammeters and a voltage source. So I use my voltage divider and I keep changing the voltage. So there are three variations. So for a given circuit, I'll show you three readings. So what you have to do is, I would have connected all of this. Then you have to check the ammeter reading. I change the voltage, again check the ammeter reading. Again I change the voltage, you check the ammeter reading. So this is version 1 or case 1, circuit 1. And in circuit 2 and 3, I use LEDs, one resistor and one LED, and ammeter, voltmeter, sorry, not voltmeter, but ammeter and your voltage source remains the same. So we will be looking at three different circuits. Again, in all of it, you have to read the ammeter reading. Have a look at it. Okay. So the circuit is a bit complicated to look at because there are too many wires running. So I don't have the actual circuit on the screen as of now. So you guys don't bother to figure it out. It's a bit too many wires are there. It's not complicated. Too many wires are there. So don't bother. So one thing is, please take into account that there are too many wires, and um, I mean, the devices are not that great, so you might end up uh, reading a bit different values in both of it. A bit different, not too much, a bit different. So my request is, don't bother with that. Take an average, right? And end of it, fill this black. Okay. So now have a look at the video. So what did you guys read? Well, the ammeter read almost the same value in all the cases, is it not? Right? That's what the question talks about. So anything connected in series, the electronic components will have the same current flowing through it. Simple reason, you can see it in uh, your resistive paths, right? This particular circuit is the same thing happening over here. So how do you write this in your exam? Quite simple. First, we'll start off with writing down the apparatus, things that we'll be using. I've used two resistors, or you can use three also, 2 to 3, or any number of resistors you want. It's just drawing now. It doesn't matter. So I have two resistors minimum. You can have three resistors also. Ammeter connected in series with voltage. Sorry, all of it. And positive end is connected to positive end. Negative end is connected to negative end of the ammeters. Then all you have to tell is current the circuit as shown in the figure. Plug in the key. Note down the reading in both the ammeters. What do you observe? All the ammeters read the same. In the lab equipments or in a better equipment, you'll see a constant reading of the ammeters. And then conclusion, whatever the question tells, you just have to write it down. In a series combination of resistors, the current is same in each part of the circuit or the same current through each resistor or electrical component. Okay. So you can end up with this particular writing. That's it. So, and now you can just end up copying some of it. If any idea you guys got it from this slide, please make a running note. And this is your answer, 3 or 4 marker question answer.